Hello, welcome to this session of electrical energy, and we are looking at electric heat energy. And under the electric heat energy, we are going to look at it that the electric heat energy has this relationship is denoted with H, and it is measured in with the formula I square RT, I square RT, and then this is an agreement with Joule's law of electrical heating, which states that the heat energy produced in a wire as a result of electrical current passing through it is proportional to number one, the current, that means the resistance of the wire, and also the square of the current and the time. So when you look at this relationship under electrical energy or electric heat energy, we are going to look at the formula and how this explain what we refer to as Joule's law of electric heating. As you can see, we we are going to look at how we can use it to solve various questions. And once again, I would like to write what the law states as we have it. Now is um, this is in agreement with Joule's law of electrical heating, which states that energy produced in a wire as a result of electrical current passing through it is proportional to figure 1, the resistance of the wire the square of the current and the time. And that's why you can see it in that relationship that H is equals to I square RT. I square RT. And from Ohm's law, we could see that H is equals to IVT, and also that H is also equals to V square T over R, V square T over R, which is equals to PT. P is the power, and from there we can see the relationship between what the electrical heat energy is all about and what it entails, as you can see it here. So, and from here you are going to see solution to several questions based on this relationship and based on what we have stated here. So let's see what we have in the questions and how to apply these equations to solve various questions under what you have as electric heat energy. Now the question here says that a work of joules is done in transferring 5 millicoulombs. Solution. Solution. Now what we are given here, 5 millicoulombs, we are given the charge because what we are considering is the work done in electric field. The work done in electric field, and that's W, which is equals to QV. So from here we could see that what are the parameters that we are given. We have the given data that we have the work done. Work done, that's the W, is given as the 30 joules. Is given as the 30 joules. A work done of 30 joules. Here you have 30 joules. 30 joules. And the charge Q is 5 microcoulombs. 5 millicoulombs. Okay, you have it as 5 millicoulombs. As you can see it there. Oh, it's millicoulombs. That's M. Then we are asked to calculate the potential difference. Potential difference which is V, is W over Q. And what is W? W is 30 joules divided by 5 millicoulombs is times 10 raised to the power minus 3 coulombs. And from there, this is going to be 30 times 10 raised to the power 3 over 5. 5 goes there 1, 5 goes there 6. So the answer is 6 times 10 raised to the power 3 volts. And that's how we calculate it, as you can see from the calculation. That's the easiest way to calculate the question. And let's see what we have also in other question, as you can see. Now let's see what we have in the second question. Calculate the resistance of the filament of a lamp rated 240 volts and 40 watts. And from here you could see that you are given the power. Let's see what we have in the solution. Under the solution here we have the potential difference, which we have as 240. The potential difference, that's V, is 240 volts, and we have the power, and that's W, and that gives us 40 watts. So the next thing is to calculate the resistance of the filament. And how do you calculate the resistance of the filament? We could see that P is equal to IV, and here we want to calculate the resistance and current is not given. And from Ohm's law, we could see that V equals to IR. V equals to IR, and R is equals to V over I. And since we have I This is I. I also is equals to V over R. So substituting that into the power equation, we say P is equals to I is V over R then times V, and that will give us V square. That will be V square over R. Okay. So now from here, what is our V, our R? Our R is going to be V square over P, and that is 240 square divided by 40. You have 240 times 240 divided by 40. 0, 0, 4 goes there, 4 goes there, 6. 6 times 24 is 1440. So that's 1440 ohms. And that's how we calculate that. And you can see the way it has been demystified for you step by step on how to calculate the resistance based on the calculation that we have here. Okay, let's see what we have in the next question.
Okay, now see what we have in this question number 3. The maximum power dissipated by a 100 ohm resistor in a circuit is 4 watts. Calculate the voltage across the resistor. Now, let's see the solution. Now, firstly, the given data that we have here, we have the resistor. And that is 100 ohms in a circuit, and we have the power. P is 4 watts. Then from here, we want to calculate the voltage across the resistor. Voltage V is unknown, and we know that power is equals to IR, IV. So, and we are given the resistance. The resistor, we are given the power and we are given the voltage. Though we are looking for the voltage, and also we know that current from ohms law is equals to V over R. Now, from on substitution, we have P to be equals to V over R times V, and that is going to be V square over R. V square over R. So from here, we could see that the power, which is V square over R, and now the voltage. How do you calculate the voltage? The voltage is equals to, that's V square is equals to PR. Then V is now equals to the square root of PR. And that's the square root of P, which is 4, times R. What's the value of our R? That's 100. And that's the square root of 400. And therefore, our V is equal to 20 volts. And that's how we calculate the question in a demystified way, as you can see step by step. And this is coming from Covenant Achievers Academy. There is currently an online class going on. Be part of the class. And how do you be part of the class? Click on the WhatsApp link in the description below or in the Learn More, where you have access to the class. It's a free class that is going on. I want to be part of this. Once you are on the WhatsApp group, you are going to see how we demystify every aspect of physics, mathematics, and chemistry for you. See you in class as you click on the WhatsApp link.